So today I'll teach you something about vectors. Vectors are those physical quantities that have both a magnitude as well as a direction. The contrasting quantities, that is the scalar quantities, only have a magnitude but no direction. Okay, let's see an example. Let's say we have an object moving with a speed of 55 meters per second. If we only specify the magnitude, this quantity will be a scalar quantity, and if we add a direction to it, say the object was moving towards north, and we say that the velocity of an object is 55 meter per second towards north direction, then the quantity is a vector quantity. Okay, now let's see how can we geometrically represent a vector. A vector can be represented geometrically by a straight line like this. This directly, the length of the straight line is directly proportional to the magnitude of the vector. Magnitude, the longer the straight line, the more is the magnitude. And for the direction, we can have an arrow pointing towards the direction. Okay, so this above part we see is called the head, and this lower one is called tail of the vector. Okay, now let us write a vector. We can name a vector. Suppose we have this vector as a, and to represent that a is a vector, we can have an arrow above it, or just a fishy arrow above the alphabet like this. So let's say a was a first vector of say 5 Newton, and let's consider the directions to the standard ones. Upward will be the north, so this direction will be east. Now let's see how can we compare two vectors. For the comparison of two vectors, keep in mind the thing that we need to compare both the magnitude of the vector and the direction of the vector. So let's consider two vectors to be like this. Say this is a vector of force vector of say 4 Newton towards east, and let's have a second vector as b vector a bit longer than this. Suppose b vector is 5 Newton towards south. This is also a force vector. So you see both the direct magnitude as well as the direction of the two are different. Hence a and b are unequal vectors. Now let's see some other thing. Right? If we have b vector of 4 Newton towards south, you can again see that the direction is still different, though the magnitudes are same. Hence vector A is still not equal to vector B. And now suppose we have vector B in something of this sort, 4 Newton towards east. Then you see both the magnitudes and directions are same. Hence vector A is equal to vector B. Okay, now moving on to the operations on vectors. Firstly, let's discuss the addition of two vectors. Okay, the addition. Let's say we have a vector A and a vector B, and we have defined a vector C to be a sum of A and B vectors. So vector C can be geometrically represented as, first we need to draw vector A. Suppose it's the same as vector A. And now be careful, you need to draw vector B in such a way that the head of the vector A coincides with the tail of the vector B. So vector B will be drawn in this way. And now you need to simply join the tail of the first vector to the head of the last one and direct it to the head of the second vector, like this. So now this one is C vector, that is the sum of A and B vector. Okay, we are done with addition then. Now let's move on to the subtraction. Um, okay, now subtraction. Okay, let's say we have a vector A and a vector B. So now you see we define a vector C in such a way that C is the difference of A and B vectors. So we can also write this as C is the sum of A vector and the negative B vector. So now what's this negative B vector? Let's see. Let's figure it out. So B vector is like this we have. So the negative B vector will be of the same magnitude, but the direction will just be the opposite one. So this is the minus B vector. Now it's simple. It's just addition of two vectors. So let's add them. So we can have A vector and the B vector like this, and let's join the two. So we get the C vector. This was a subtraction. Now the multiplication of vectors. Multiplication of vectors is of two types: cross multiplication and the dot multiplication. But that we'll see later. First we'll see the multiplication of a vector by some scalar. Suppose we have a vector A. This is a vector A, and we want to multiply it by 2. So the resultant will be a vector with twice the magnitude of A, but the same direction. So this is 2 into vector A, or simply 2A. Okay, that was all. I'll see you in a later video.